Welcome to Lecture 4 on using explicit cursors in PL/SQL programming. In Oracle, whenever an SQL statement is executed, the system creates a special memory area called a context area. This area stores all the information needed to process the statement. A cursor is simply a pointer to this context area. In PL/SQL, cursors play a very important role. They allow developers to work with the results of a query one row at a time. This is especially useful when a query returns multiple rows. Instead of handling all data at once, PL/SQL uses cursors to process each row step by step. A cursor can return one row, many rows, or even no rows at all. Understanding cursors is essential for effective database programming in PL/SQL. In PL/SQL, there are two main types of cursors: implicit cursors and explicit cursors. Implicit cursors are automatically created by the Oracle server whenever a SQL statement is executed. Developers do not need to declare them. Oracle uses these cursors to parse, execute, and manage SQL commands behind the scenes. On the other hand, explicit cursors are defined and controlled by the programmer. They are used when a query returns multiple rows and you need more control over how each row is processed. By declaring explicit cursors, you can open, fetch, and close them manually, giving you greater flexibility when working with data. A cursor is a powerful tool used to retrieve data from an Oracle database. It not only executes a query but also stores the structure of the data being retrieved. A cursor includes the definition of columns, the source objects such as tables or views, and the conditions that determine which rows will be selected. Let's look at two simple examples. The first is a basic SQL query: select name from employees. The second example shows an explicit cursor. Cursor getEmpl is select name from employees. Both of these are used to retrieve data. That is the main purpose of cursors, to access and process data efficiently. In PL/SQL, implicit cursors are created automatically at runtime. You do not need to declare them manually. Whenever a DML statement like insert, update, or delete is executed, or when a select into statement is used, PL/SQL creates an implicit cursor behind the scenes. Let's look at an example. We declare a variable called vDate and then select the hire date from the employees table into this variable for employee ID 105. When this code runs, PL/SQL automatically creates a cursor to retrieve that value. So the cursor is implicitly defined during execution, making data retrieval simple and efficient without extra coding. The select into statement is a common example of an implicit cursor in PL/SQL. It shows how we can query data directly inside a PL/SQL block. This type of statement is designed to retrieve exactly one row of data from a table and store it into variables. If the query returns one row, it works perfectly. However, if it returns no rows or more than one row, PL/SQL will raise an error. So, select into is useful when you are sure that your query will return a single result. It is a simple and efficient way to fetch data using implicit cursors. An explicit cursor is a cursor that is defined by the programmer before execution begins. It is based on a select statement that you write and control manually. The basic syntax starts with the keyword cursor, followed by the cursor name, and then the select statement that defines the data to be retrieved. For example, we can declare a cursor named curs_or, which selects employee ID from the employees table, where the department ID equals 100. This cursor will return all employees in that specific department. Explicit cursors give you more control over how data is fetched and processed in PL/SQL programs. When working with explicit cursors in PL/SQL, there is a clear sequence of steps that must be followed. Following these steps ensures that explicit cursors are used efficiently and correctly in your PL/SQL programs. In this diagram demonstrates the sequence of explicit cursors step by step. First, you declare the cursor and define the data structure that will store the retrieved rows. Second, you open the cursor. This step executes the query and prepares the result set. Third, you fetch the data row by row. This allows you to process each record sequentially. Finally, you close the cursor to release the memory resources. Let's look at a simple example of using an explicit cursor in PL to SQL. First, we declare a cursor named curs.getEmployee. It selects the hire date from the employees table for employee ID 105. We also declare a variable vDate to store the result. Next, we open the cursor. This executes the query and prepares the data for retrieval. Then we use the fetch statement to retrieve the data from the cursor into the variable. Finally, we close the cursor to release system resources. This example shows the full lifecycle of an explicit cursor in action. This example demonstrates how to use an explicit cursor along with cursor attributes in PL SQL. First, we declare a variable senumber and define a cursor named cursor, which selects employee IDs from department 100. Then we open the cursor and fetch the first row into the variable. After that, we check the cursor attribute %not found. If no rows are returned, we assign a default value of 9999 to canumber. Finally, we close the cursor and return the result. This approach helps handle situations when a query does not return any data, making your program more reliable. In this example, we work with multiple explicit cursors in a single PL SQL block. First, we declare two cursors, 1 and 2. Each cursor selects the hire date for a specific employee, employee 100 and employee 101. We also declare a variable vDate to store the results. Next, we open the first cursor, fetch its data into vDate, and then close it. After that, we open the second cursor, fetch its data into the same variable, and close it. This example shows how multiple cursors can be managed sequentially to retrieve different sets of data within the same block of code. At first glance, implicit cursors seem simpler and faster to write. However, explicit cursors offer significant advantages that justify the extra code. One key benefit is their cursor attributes, which make it easy to use conditional logic when processing data. For example, suppose we want to find an order and if it exists, perform some actions. Using an implicit cursor requires handling exceptions to check whether the record was found. In this code, we attempt to select the order date into a variable. If no data is found, we set a flag to false. Otherwise, the program continues normally. This shows that explicit cursors give more control and simplify conditional operations, making your PL SQL programs more robust and easier to manage. When using an explicit cursor, the code becomes much clearer and easier to understand. In this example, we declare a cursor named cursGetDate, which selects the order date for a specific order. We also declare a variable to store the result. After opening the cursor and fetching the data, we can directly check the cursor's %not found attribute. This tells us whether any row was returned. If no data is found, we can perform the necessary action immediately without needing an extra block for exception handling. Finally, we close the cursor. This approach makes the logic straightforward and the program easier to maintain. In PL SQL, cursor attributes provide useful information about the state of a cursor during data processing. %bulk row count tells us the number of records returned by a bulk collect into operation. %found is true if the last fetch operation successfully retrieved a row and false otherwise. %not found is the opposite. It is true when the last fetch did not return a row. ISOPEN indicates whether the cursor is currently open or closed. Finally, %row count shows the number of rows that have been fetched so far. These attributes make it easier to control and monitor cursor operations in PL SQL programs. Some cursor attributes are also available for implicit cursors, but program logic is often much easier with explicit cursors, especially when dealing with multiple cursors in a block. For example, we can check the %row count of one cursor and the %found of another to control the flow of the program. In this code snippet, if curs get order sut row count equals 1 and curs get details sent found is true, we proceed to process the order details. Explicit cursors make it straightforward to combine these checks, improving clarity and maintainability of your PL SQL programs. In this example, we use for all to perform bulk updates efficiently in PL SQL. First, we declare a table type containing employee last names, Grant, King, and Donald. Then the for all loop updates the salary for each employee whose last name matches the list, increasing it by 10%. After the update, we print the total number of rows updated using SQL% row count. Next, we loop through each name and check SQL% bulk row count for that iteration. This allows us to see how many rows were affected for each specific name. In this case, Grant and King had matching rows, while Donald had none. This demonstrates how bulk operations and cursor attributes can efficiently handle multiple updates and provide detailed feedback. In this example, we use an explicit cursor to retrieve multiple columns from the employees table. We declare a cursor named CMP cursor that selects employee ID and last name for departments 10, 20, and 30. We also declare variables to store each fetched row. Next, we open the cursor and start a loop. Inside the loop, we fetch each row into the variables and print the employee ID and last name using DBMS output put line. The loop continues until the cursor attribute %not found indicates that there are no more rows. Finally, we close the cursor. This approach allows us to process multiple rows sequentially and display their values efficiently. Thank you for listening. We appreciate your time and interest in this topic.